Cyclic acetal. Why do we care for the organic chemistry? It's explaining. Think about these reactions. You have a grignard. You got grignard. That carbon is a nucleophile. And then you have a carbonyl. So if you don't think much, you may consider that this carbon, they can attack this carbon, opens it up, then you can get this product. That is something that you can easily predict, but this is not going to happen. Some of you already imagine why this is happening, because your grignard already have a carbonyl to react with without having that. So that's the reason why this is not happening. It becomes a problem. If you don't have that, this grignard may can attack, may can alcohol, the same grignard reaction that you have seen before, nothing special. Only issue is your grignard reagents have a carbonyl. So all we need to do, we just have to mask carbonyl of the grignard reagents. Then reaction will happen, and then after reaction is completed, you just have to release that mask, and then you get the carbonyl back. So that's why you need a protecting group. Sometimes if you have to protect something or mask something for the reaction that you want to carry out, and at the end, you're going to release it, you get the functional groups back. So how you should do it is, before making grignard, you have a carbonyl as an aldehyde there. So we can do what we just talked about, making cyclic acetal with an diol. Same thing that we just talked about. Aldehyde here, we got the diol, so it's going to make a cyclic acetal. To this, you can treat the magnesium, then you can make a grignard. That becomes a grignard, there's no issue because there's no carbonyl to react with. So that's why we call it protecting groups. Acetal is protecting the carbonyl. Or you can imagine you mask the carbonyl. Then this grignard, they can attack to this carbonyl of the reactant, and you get these forms. And then protonation, you get the grignard reagent, it's protonated. At the same time, acetal will release out in acidic water to become an aldehyde. So you can make something even though you have a problem. That's how you should use the protecting groups. These strategies, it's not the first time we talked about it. If you remember that chapter 14, even though it didn't appear in the test 2, cilial protecting groups is used to mask the hydroxyl groups. Hydroxyl groups can be protected if it becomes an issue. When the carbonyl becomes a problem, you can mask it with an acetal. So different protecting groups does different things. So now you know how to protect an alcohol. Now you know how to protect the carbonyl. There's a different types of protecting group for the carboxylic acid or even amine just to achieve the synthetic goal. But using the protecting groups make things possible, especially complications like this exist. Then you basically temporarily mask it and then do the reactions and release it. So that is kind of a strategy we're talking about. Carry out these reactions. What you see here is we got carbonyl becomes an alcohol, adding a methyl groups. So that can easily think about, oh, the grignard. You got the methyl grignard. That makes an attack to carbonyl. That opens up, you get this. I'm pretty sure that I will get this answer out by asking you this question the test. This is not the correct answer. Even though you may think it goes this way, it doesn't. Why it doesn't? Because of this molecule, not only having a one carbonyl, it has another one. In fact, if you remember that, which one of these two carbonyls are more reactive? This is a carbonyl of the ketone. This is a carbonyl of the aldehyde. Which ones are more reactive? Carbon chain reduce electronegativity, right? Reduce electric efficiency. So less number of carbon makes it more reactive and more open up the spaces. So the aldehydes are more reactive to the ketones. So even though you are thinking about adding grignard, is not going to attack that first. Grignard is going to attack the aldehyde first, and then you get this first. So that's not what we want to make. The problem, it basically points out what is a problem. The problem is having the aldehyde functional groups right there. That's the problem. If there's no aldehyde functional groups there, we are making attack, having these forms easy. There's no problem. So when you have a problem like this, what do? You protect it, right? How you protect the carbonyl of the aldehyde? That's using cyclic acetal that we talked about. This 2-carbon chain is used because it makes a 5-member ring. If you have a 3-carbon chain, it's going to be a 6-member ring, but it's going to be cyclic acetal anyway. So you create an acetal using this ethylene glycol. Then you prepare these things. You got 2 carbonyl there, but we already talked about which carbonyls are more reactive, aldehyde. So even though you have this one's going to be react first. And you are protecting aldehyde with an acetal. That leaves the carbonyls only there. So Grignard can be used without any complications. Grignard makes an attack, you get that forms, still have an acetal, we have to release it out. How to release an acetal to the ketones and aldehyde? Just putting in acidic water. So then it'll open up, you get the aldehyde back. So this is a kind of a things for you to recognize. When you have a trouble because of a particular functional groups get in the way, then protecting group strategies might be useful. So this is the occasion to show you to think this way. All right, next reactions are very much similar. You got double bonds formed, and then you got the aldehyde. So if you remember that, oh, that must be the Billig reactions reacting with aldehyde. Then you may think that, okay, the triphenyl phosphate makes an attack and make it base, right? You get the ionic forms, and then you got that part as an aldehyde. This makes an attack that one, making a double bond, you can create that. If you answer that, I would say, yeah, that's a good effort because you recognize how to make the double bonds, but it's not a complete solution. The problem is, this is something that you want to do it. These reagents have seen this level already. Extra carbonyl becomes an issue. It's basically saying thing again. Carbonyl becomes an issue. These Billig reagents attack this carbonyl, then you're going to make that. That's going to make this reaction again. You got a lot of things prepared. So this is the problem of the carbonyl hanging around, and that's getting again. So what do? You protect it. So I'm pretty sure that now you understand why we want to do these things. The question is, at the time it passed, I will still remember that. Anyway, protecting carbonyl is a pretty simple step, right? You just have to treat the diol and then an acid, and you're going to get the cyclic acetal forms. Once it becomes an acetal, then none of those reactions will happen to the acetal unless you open up the acidic one. So you can easily make an SN2 reactions and then put the base to make this ionic, that reacting with the aldehyde to make a double bonds, fine, everything goes fine because there's no trouble carbonyl there. But in the end, you're going to release that to make this back again. So that can be done just putting in an acidic water. So that is the protective strategy.